All right, AP Calc, let's do this. So let's get a problem going with a cube. Let's see, it says the volume, not volume, it should be the volume. So the volume of a cube is increasing at a constant rate of 33 cubic inches per minute. So how can we translate this first sentence? Let's see. So the volume is increasing. So what's given? The capital V dt is equal to a positive constant rate of 33 cubic inches. So 33 cubic inches per minute. Okay. At what instant? At the instant when the side length of the cube is 22 inches. So we know that the cube has a side length of 22 inches. What is the rate of change of the surface area? So here, how do we translate this part over here? This will be d capital S dt. So what's going on here? If you have some sort of cube, let me try and draw a cube. Okay, that's not too bad. So if you have a cube, what's happening to the side length of the cube? It's increasing every second by 22 inches. So first the cube is here, then it's going to grow and grow and grow. So the idea of volume, for example, if I have, like, let's say my coffee over here, volume is, how much coffee is inside the cup, right? But the idea of surface area, you have to think of surface area as, if I have this cylinder, how much actual, paper is on the surface of this container. It's not how much is inside, but how much is around. So when you think of this cube over here, the cube, how much can you put into the cube is volume, but how much is on the outside of the cube represents surface area. So here, you're given this. But what do you know? What is the volume of a cube? How do you actually find it? It's given this formula S cubes, because you just have to multiply the sides 3 times and you'll get the volume. To get the surface area of a cube, what would it be? It should be 6 times a squared, because you have 6 sides of a cube, and a squared, or I'm sorry, it should be a 6s squared. Yeah, 6s squared. 6s squared. That'll work. Okay. So what do we want to find? It's saying find ds dt. So what would be the first move? Let's take the derivative with respect to time with the formula for surface area. So surface area, this should be d capital SA. You know what? Yeah, because surface area is SA, so dSA, because the derivative of the surface area, or the rate of change of the surface area. So if we have SA, right, equals 6s squared. Now we're going to take the derivative with respect to time for here. So then what do we have? We're going to take d dt on both sides. So this is going to be d dt on both sides. And now here we're going to have dSA of dt. So this is the rate of change of the surface area is equal to, now we have to take the derivative of this. So this should be 12s ds dt. Okay. Now how do we continue further? Do we know what this is? No. Do we have 12? Yes. Do we have S? No, we don't have S. I'm sorry, we do have S. It's 22 inches. And we don't have ds dt. We don't know how the side is changing per second. So what can we look into? Here, let's take a look at this part over here. If you know that the volume is equal to S cubed, maybe we could take the derivative of this with respect to time and somehow get this ds dt. Well, let's take a look. If we take d dt on both sides, notice that we get dv dt is equal to 3s squared, 3s squared ds dt. Now notice what happens here. Do we have dv dt, remember what the game plan is. The game plan is we want ds dt, because if we have ds dt, then we could find dsa dt, right? So how can we find this ds dt? Do we have dv dt? Yes, we do. So this is 33 inches. Do we have 3? Yes, we do. Do we have s squared? Yes, we do. Because s squared, s is 22, so it's just 22 squared times ds dt. So notice, what was the point of doing this over here? Now we can get ds dt by itself, because how do you continue with this? Let's actually, let me get, do I have a post-it here next to me? Okay, hold on, sorry. Ugh. Okay, gotta post it here. How do you actually continue with this? If you have 33 is equal to 3 times 22 squared ds dt. So now 33 is equal to, what is 22 squared? Okay, let's do it. What is 3 times 22 squared? This should be 1,452 ds dt. Now we're going to divide. So now how do you get ds dt by itself? Divide the 1,452 on both sides. So 33 divided by 1,452 is equal to 0.022727. Yeah, 02. Yeah, so it's just bar over here. Okay, now what does this ds dt mean? This ds dt means that every second your cube, the side of the cube is increasing by 0.022727 inches per second. That the side of the cube is increasing. Now that we know this ds dt, we could plug in it over here. So we have d capital SA dt equals 12 times, what is our s value? 22 times this 0.02727, right? And then that's it. And then we get ds capital A dt is equal to, you just multiply these numbers. So here times 22 times 12, and notice it should be 6. So what this is saying is that the surface area is increasing by 6 inches squared per minute. Okie dokie. It's saying that when the cube keeps increasing, the surface area is going to increase at this rate per second. I'm sorry, per minute. Okie dokie. Let's try one more problem, then we're done. Here, this will be a little bit more difficult. Here, it's saying the volume. Okay, let me move this back a little bit. Okay, let me move this back. Okie dokie. There we go. So now here it's saying the volume of a sphere is decreasing at a constant rate of 897 cubic centimeters per minute. So we have some sort of sphere, and the sphere is just getting smaller and smaller per second. Okay. Now the volume of the sphere is decreasing, so you're given that what I want you to do is try and do this by yourself, right? So the capital V dt is equal to negative 897 cubic centimeters. So cubic centimeters per minute. That's the first information. Second information, at the instant when the radius of the sphere is 66 centimeters. So you know that your R value is 66 centimeters. What is the rate of change of the surface area? So you want the capital SA dt. Let's see, at the instant when the radius of the sphere is 66 centimeters, what is the rate of change of the surface area? Okay, now here, okay, instead of SA, you could write capital S. I'll just say SA. I like SA. Now, what do you know? You know that the volume of a sphere is 4/3 pi r cubed. And what's the surface area of a sphere? It's 4 pi r squared. Okay. So what do we want to find? We want to find the rate of change of the surface area. So let's see what happens. If we take the surface area and it's equal to 4 pi r squared, let's take d dt on both sides. So d dt. And now what do we get? We have d capital SA dt is equal to, what's the derivative of 4 pi r squared? Notice that the 4 pi is a constant. So what's the derivative of r squared? We're going to multiply it 2. So notice it's, if you have 4 pi, right? And then we're going to take the derivative of r squared. So that's 2 times r dr dt. Sorry. But then that's the same as d capital SA dt is equal to just 8 pi r dr dt. Okay? Now what happens here? We want to find this. Do we have 8? Yes. Do we have pi? Yes. Do we have r? Yes. Do we have dr dt? No. We need to find dr dt somehow. So what are we going to do? Let's look at this formula. If you have v is equal to 4/3 pi r cubed, let's take the derivative of both sides with respect to t. So if I take d dt on both sides, notice that this becomes what? This is d capital V dt equals, what is the derivative of here? This will be, notice that this 4 pi over 3 is a constant. So this will be times, what's the derivative of r cubed? It's 3r squared dr dt. But then what happens with these two 3's? They cancel. So we have d capital V dt is equal to 4 pi r squared dr dt. Okay? Now, once we get to this point, what do we want to find? We want to get this dr dt by itself, so we could plug it in. Do we have dv dt? Yes, we do. We do have dv dt. What is it? It's negative 897 equals 4 times pi times 66 squared dr dt. Now we have enough information to actually get this dr dt by itself. So this becomes what? We just have to use the calculator. So this is negative 897 excuse me, equals, no, I don't have the coronavirus just because I sneezed, right? 4 pi times 66, oh, and I gotta sneeze again. Excuse me. So 4 pi 66 squared, we're just doing that here, and that's 54739.1104 dr dt. Now let's divide both sides by 54739.1104, and that's our dr dt. So if I have negative 897 divided by 54,739.1104, that equals negative 0.0163868,209, and that is our dr dt. What does this dr dt represent in the context of the problem? I'm running out of ink here. What does it represent? This is the change in r. What does the change in r represent? It's the radius of the sphere. It's saying that every second the sphere's radius is decreasing by this many centimeters per minute. Okay? So now that we know what dr dt is, what do we have to do? We just have to plug this number over here. So now we just have to do 8 times pi times 66 times, sorry, because we're just doing this, 8 times pi times 66. And what is dr dt? It is negative 0.0163868,209. And now we have that this d capital SA dt, the rate of change of the surface area, is equal to negative 27.18181813, but that just rounds to negative 27.181, I'm sorry, 2. And then what will it be with respect to what's going on here? It'll be centimeters squared per minute. Okay, so it's saying that the surface area of the sphere is decreasing by 27.182 centimeters squared per minute. Okay, not too bad, but good luck. What I want you to do on Delta Math, I'm gonna try and do at least one of each question. Okay, don't just skip and do all the circles or all the squares or something. Try and get one of each, and I will check. You got this. I believe in you. Good luck.